Good morning, dear students. I hope you're all well. Welcome to grade 10, module 9, lesson 4. And today we are looking at solving systems of equations graphically. So when we get a question that states that we need to solve systems of equations graphically, there are certain things that's expected of us. Firstly, we need to determine the number of solutions for each system, and then we are required to state whether the system of equations is consistent or inconsistent, and whether it is independent or dependent. So we have 6 examples to consider. The first step is to ensure that it is written in Y form. So if we look at the first example, we can see that it is written in Y form. But when we go into the other examples, we find that some are written in Y form and some are not written in Y form. So the first step to ensure that we are able to get to the correct solution is that we write it in Y form. So let's go through the learn part very quickly and understand what is expected of us in this section. So we are given 2 equations, and therefore it's called a system of equations because it is a set of 2 or more equations with the same variables. That is, they will have x and y generally. And the one method that we are going to use today, and we're going to be very smart at the very end, is to see how each function is related. So if we look at the first one, we can see we have 2 lines here, 2 equations, equation 1 and equation 2. So let us analyze this. We can see that the lines intersect at one point. So they intersect at one point. This is the point of intersection. And we can also see that they have different slopes, right? They have different slopes. So it means that it only has one solution. This brings us to concluding that the system is consistent because there is at least one solution. It is independent because it has exactly one solution. Going on to the second one. The lines are identical. That means both the lines graph onto each other. There are 2 lines here, and when graphed, they end up being on each other. So we say the lines are identical. They have the same slope and the same y-intercept. The lines have the same slope and the same y-intercept. Therefore, there are many solutions, infinitely many solutions. The system is consistent and dependent. Dependent because there are infinitely many solutions. Going to the third system of equations, we can see very clearly that the lines are parallel to each other. Right? We have 2 parallel lines. Right? The lines are parallel. The lines have the same slope, but different y-intercepts. As we can see here, both these lines cut the y-axis at 2 different points. Right? but they have the same slope. We can also see that there is no crossing over anywhere. There is no crossing over of these two equations. So that means that there are no solutions. And this brings us to the conclusion that the system is inconsistent because there is no solution. No solution, so the system is inconsistent, but they have the same slope and different y-intercepts. So let us see how we go about answering the rest of the questions. In example 1, they ask us to classify system of equations and then determine the number of solutions the system has. Then state whether the system of equation is consistent, inconsistent, independent, or dependent. As you can see here in the first equation and in the second equation, both are not written in y form. So step 1 is to always solve each equation for y. So the first equation, when we solve for y, will give us the resultant of y is equal to 3x minus 7. And so will the second one, y is equal to 3x minus 7. So what can we deduce after that? We can say that the equations have the same slope. Once again, where is the slope? The slope is the 3. Right? The variable before the x is the slope. And we can see that both equations have the same slope. And then the next one is that they have the same y-intercept. So this is my y-intercept. And we can see both the equations have the same y-intercept. So very quickly, we can conclude that both equations represent the same line. So they have the same line. The system has infinitely many solutions because it's exactly the same. And therefore, it is consistent and dependent. Consistent and dependent. So let's move on to see how do we solve the rest of the equations. If we look at the first one, we can see that you have positive 3 and negative 3. So that represents my slope. Are they the same or are they different? We can see that they are different. And then I go to my y-intercept. In this case, my y-intercept is plus 2. And in the first equation, it is going to be 0. So you can quickly add a 0 here. And you can see once again that they are different, right? Your slopes are different and also your y-intercept is different, right? You have 0 there and you have 2. So we can say that they are different. Therefore, they have one solution and they intersect at one point. And we can now conclude that it is consistent and independent. So now you would do exactly the same, follow the same steps. Step 1, solve each equation for y. Solve each equation for y. Then determine whether the slopes are the same, whether the y-intercept is the same and different, and then you would be able to conclude whether they intersect at one point, many points? Are they consistent and independent, or are they do they have many solutions, one solution, no solution? And you would be able to explain these examples very easily once you have worked through all these examples. As usual, every accomplishment starts with the decision to try, so never stop trying. All the best until our next session.